Hey Pre-Calcers, today we're going to be going through the P1 practice, which dealt with problems 1 through 15 odds, 21 through 33 odds, and 91 through 95 odds. The first 15 are very similar to what we saw in the video where we were just taking numbers for X or for Y and then just plugging in and evaluating them. Some of these are going to be super simple, so I won't show all the work, but if you have any questions along the way, you can shoot me an email or ask in class. So for these, we're given an algebraic expression, we're given a value that we can plug in for. In this case, we can say that x equals 10, so we just plug in accordingly. 7 plus 5, we put in 10 there. What's this product going to be if we have 5 and 10? You can really think of this as 7 and you're adding on 15, which gets you 57. So that one's pretty simple. 3 is kind of the same idea, but now we have two variables to focus on. So we can say that x is going to be equal to 3 and y is going to be equal to 8. So let's do that. So we have 6 multiplying with our new x, which is now 3. We can then subtract that 8. 3 times 6 is 18. Deduct 8 gets us 10. So that's 3. Notice that I'm just doing the odd numbers. The even numbers, we'll practice that in class. For the next one, we have a term with x being squared, so we'll take the same song and dance. We're going to be squaring 8, adding on 3 times 8. 8 squared, remember, is 8 times 8, so that's 64. 3 versions of 8 is going to get us 24. Adding that together and getting 88. Pretty simple for these first few. 7, we're going to get 7 being squared. We're subtracting 6 times 7. We're adding 3. What's nice about these problems is that once you have just addition and subtraction set up, you can just take it from left to right. I think students get stuck into the concept of just focusing on the right-hand side, but you can really just start at 49. Deduct 42, which is going to be 7, and then 7 plus 3 gets you 10. So I think that's the best way to approach it. Definitely writing out the work for some of the more difficult ones, but be consistent with how you're going about solving for those. Got a different scenario now with parentheses. We haven't seen one like this, but we're still going to plug in where x is 9. So we'll take 4 plus 5. In parentheses now, it should be 9 minus 7, which is just going to be 2. Here, be careful. You don't want to combine the 4 and the 5 just yet, because 5 has this bit of 2 cubed added onto it, where they're multiplying. So I think the best thing is think of order of operations here, where we definitely want to focus on anything in parentheses, which we did. We then have some exponent work, so let's do that. If we have 2 cubed, we can treat that as 2 times 2 times 2, which is just 8. And then from here, if we continue order of operations, we can then multiply or divide. 5 times 8 is going to get you 40. 4 plus 40 gets you 44. And we're done. That, I think, is one of the trickier ones. If 9 was tricky, that's definitely going to make 11 tricky, so we'll walk through 11 as well. So this is going to have x in place of, or 8 in place of x. So we have 8 squared. We are then deducting 3. Taking the difference of x and y, so be careful here. So 8 minus 2, that's going to get us 6. 8 squared, 64, minus 3 times 6. So really, 64 minus 18. So what's that going to be? 44? No, 46. Yeah. So that's 11. For 13, I'll write kind of in here. So let's do 5 times that 12. notice I'm already evaluating if x was going to be 10. So 2 times that 10 would be 20. 20 minus 14 gets you 6. So this is 60 over 6. But don't stop there. 60 and 6 are both divisible by 6. So you can rewrite this to 10. So that's good. With 15, be careful. You have x and y where x is negative. So 2 times negative 2 plus 3 times 4. And also x plus 1. I'll jump ahead here. Negative 2 plus 1 is negative 1. I know I can rewrite 2 times negative 2 is negative 4. 3 times 4 is 12. All over negative 1. Negative 4 adding on 12 gets us 8. Which we can then rewrite to negative 8. Good. So that's the first 15. You know what x can be, you know what y can be, they hand that to you. I think the trickiest part is double checking your arithmetic and being consistent with that. We then work with sets where we have sets given to us where we're being asked to find the intersection, and then down here we'll be finding the union. So I don't think these are too bad. There's no arithmetic you really need to focus on. Just be careful with what you're being asked. So we have 21, where the first set has 1, 2, 3, and 4, and we're taking the intersection of 2, 4, and 5. So with the intersection, we're looking for what's common between those two sets. Well, I know that we have 2 here, 4 here, 2 here, 4 here. So this set simply just has 2 and 4, and that's it. 25, we're taking the intersection. We see 1, 3, 5, 7. This has 2, 4, 6, 8, 10. There's nothing common there, so this is an empty set. So we can just leave that. If we're taking the intersection of A, B, C, and D with the intersection of nothing, well, nothing's common, so this is an empty set. There. Down here, we're taking the union. Well, I know that we have 1. We have 2 repeating, but remember, we just want to write that one time. Just one time, no need to repeat. We have 3, 4 is also seen. We also have 5. Done. Down here, we're combining everything, so this is just going to be all of the numbers up to 10 with the exclusion of 9. So we got 1, we got 2, 3, 4, 5, 6, 7, 8, 10. And if we're finding the union of A, E, I, O, U, and nothing, that means we just have A, E, I, O, U. So nothing too crazy there. It seems odd that we're trying to unite nothing with 5 terms from the set, but that's totally fair game. So you just got to think these out and be careful. We've got task of trying to combine these algebraic expressions. We talked in class about kind of working from the outside in, from the inside and work out from there. So be careful with FOILing, be careful with subtracting terms, and I'll guide you through this. So with 91, we have 5 multiplying with the difference of 3y minus 2. We're then deducting 7y plus 2. So I know 5's out here, so let's distribute this. That gets us 15y minus 10. If I distribute in this negative sign to 7y plus 2, this then deducts 7y and deducts 2. So from here, is there anything that we can combine? We have 15y minus 10 minus 7y minus 2. What do you think? Should be saying 8y minus 12. Done. With 93, this is pretty complex. There's a lot going on in here, but it should look very similar to the example we saw in the video. So starting in the way middle, I know I can distribute this subtraction sign because we're subtracting the entire parentheses. So that would be 3 minus 4y. Let's see, I can write this here. Minus 4y plus 5. In here I can combine 3 and 5. That gets us 8 minus 4y. Outside I have 3. Oh no, I already talked about that 3. All right, so now 4 is on the outside. And then we're going to eventually have 7 in the forefront. So if we distribute in that negative 4, this gives us 7 minus 32 plus 16y. Be careful with combining the 7 and then you're deducting 32. So you're going to be ending up at negative 25. Done. So we get our final answer here of negative 25 plus 16y. For 15, I'll start fresh on that. I'll see if I can just focus on. So for 95, this has the most to it. If we look way in the middle, we see that we have 6 outside parentheses. So let's distribute that in. That makes the new bracket bit 6x squared minus 12. Recall that plus 5 is still in here, so hold on to that. From here, we can combine the negative 12 and the 5, which gives us negative 7. We recall what's on the outside, we have that subtraction sign, so let's rewrite that to negative 6x squared plus 7. Think of that as distributing. Negative 6x squared plus 7 is in here, but we still have the 18x squared plus 4. So what we can combine from here would be our x squared terms. 18 taking away 6 gets us 12. 4 adding 7 gets us 11. And that's our final answer for 95. If you have any questions, let me know. Shoot me an email. I hope this was helpful. Thanks for watching.